Code 1 Maintenance. Basic electricity. Hi. You're probably here because you just don't understand the basics about electricity. And it's no wonder. College and high school teachers talk about things like Kirchhoff's law, Coulomb's law, conventional current versus electron current, and electromotive force. And what did you learn from all the teaching? Not much, right? And what's the point if you can't use it, and all you want to do is figure out why that instrument light is not illuminating, and what you learned in school just isn't helping? And if the truth were known, Professor Quackendork probably never even held a multimeter in his life, let alone used one. But it's really not that difficult as long as it's not some scientist trying to explain it. Here at Code 1 Maintenance, we aren't scientists. We're just a bunch of maintainers trying to help each other out. So here goes. Electricity is simply the flow of electrons along a wire, just like hydraulics is the flow of liquid molecules along a tube. And both the wire and tube are the conductors that carry the material that's going to be doing a job. We will talk about where those electrons come from at the end of the video. So what is voltage? In a hydraulic system, it's pressure from a pump that pushes the fluid through the tube. And in electricity, it's voltage that pushes the electrons along the wire. It's also called electrical pressure, and the nerds call it electromotive force. So think of it this way. 500 pounds per square inch in a hydraulic system is not very much pressure, and 12 volts is not much electrical pressure. But 3,000 pounds per square inch and 3,000 volts are high pressure, and both have a lot of push behind them. It takes 1 volt to move 1 amp of current through 1 ohm of resistance. So 10,000 volts can push lots of electrons. We've talked about volts, so now let's look at amps. Get the nerds involved, and they'll tell you that an amp is when this many electrons flow past a given point in a conductor in 1 second. More really useful stuff, right? Amps is also called current, so think of it like water in a creek. In the dry summer it is just a slow meandering flow, and it is easy to wade across. But after a heavy rain, it becomes whitewater rapids, where huge trees and boulders are swept away downstream. So amps is a measure of the volume of electrons flowing, coupled with speed. A typical static spark, from walking across a carpet, generates 6,000 volts and 5/1000ths of an amp. An average lightning bolt is 100 million volts and 300,000 amps. Then we have the ohm, which is the unit of resistance in a conductor. 3 things determine the amount of resistance in a conductor. 1. Its size. A conductor's resistance increases as its length increases or its diameter decreases. 2. Its material. The more conductive the material is, the lower the resistance becomes. 3. Its temperature. A rise in temperature will generally increase resistance in a conductor. Truthfully, these 3 things don't matter much to an aircraft mechanic. Engineers and nerds, yes, but not mechanics. Now that we know about volts, amps, and ohms, let's take a quick look at what's going on inside a conductor. Good conductors like copper have some extra electrons that live in an outer orbit, and are weakly held to the core of the atom. And remember, electrons have a negative charge, and that like charges repel each other. So as one electron enters the conductor, it repels one of the others and pushes it away, and then takes its place in the newly vacated outer orbit. It's like a chain reaction, billions of free electrons trying to get away from each other, but also being attracted to the core. So let's take a minute to review what we've learned. Voltage is the pressure that pushes the electrons along. Amps is the number of electrons flowing, and their speed, as they move along the conductor. And ohms is the resistance to the flow of the electrons. And electricity is simply free electrons pushing each other along a conductor. For some reason, professors and teachers seem to overcomplicate things, and here at Code 1 Maintenance, we just plan on keeping things simple. We hope that you found this video useful.